Hopefully my slides will come up at some point. Oh, good. All right. Well, it's great to be back here. I was here 2 years ago, and for me, it wasn't just yet another conference. I go to lots of conferences. The single-track format here was actually eye-opening this size of conference. And what I found was that at the end of the conference, it was like there was kind of a bonding experience. Everyone saw the same talks, everyone was in the same discussions, and it was a different feeling from a lot of conferences. So this was actually inspirational for me, and I got to run my own conference last year, and I sort of said, I want to do a single-track conference. So there was a Go to London conference. We ran it as single track for 2 days, and then we had 3 tracks on the third day, and everyone was complaining about the fact it was multiple track by the third day. So you can get spoiled by the fact that you get to see everything here. So it's just an awesome conference. So I wanted to talk, this is a new talk, I haven't given it before, and I'm going to talk about some of the things I think are hard about building monitoring tools, and what are they for, and whatever. But I'm going to start with something, who am I and what am I doing, and there's a little bit of new stuff here. So I've been at Battery Ventures for 2.5 years. I was previously at Netflix and Sun Microsystems, a whole bunch of other things. And what I do at Battery is I do obviously technology due diligence on the deals that come in. I support portfolio companies, a few of them are going to be here. Network with interesting people like you, people that are interested in starting companies, joining companies, or using stuff from them. And I mess around with a few technologies. So I'll talk a bit about that. But a little different. For this summer, I'm actually going to be spending some time doing consulting training. I've got sort of looking for opportunities to be on boards. I've got 1 board seat in place, and I'm looking for some more. And I'm still doing sort of presentations at conferences and things like that. So a little bit different of a move for me, but if the next few months, if you'd like to have me for a day or to go talk to your people about whatever, I'm basically starting something like that. All right, so 2 years ago, I was actually the opening speaker, and this is the summary of the talk, since I think about half of you were there probably, and the other half weren't. And I was basically getting grumpy about what I'd seen in monitoring tools over the years. And one of them was that by the time you finished building your thing that managed to make lines wiggle on a graph, you sort of collapsed in, hey, we finished. And it's like, no, it still doesn't do anything useful. I wanted people to spend time going beyond just the fact that I managed to suck a number out of the kernel and put it on a graph. I want to make sense of that. What can you do with it? What does it mean? How do you interpret these things? So I was trying to get people to think about that. The other thing was I'd been annoyed by things that would do like 1-minute updates on your data, because if you flip on a feature enable and your site goes down, you don't want to find out minutes later. You need to find out seconds later. So we're in a mode now where with continuous delivery and a lot of feature flag-based deliveries, you really have to have things where when something happens in the real world, your tool should show you in a reasonable time, and I think 10 seconds is a reasonable amount of time. There's also quite often just garbage numbers being reported by tools, and you have to go figure out, are you actually measuring the thing you think you're measuring? Do you have enough resolution? There was an interesting report by actually New Relic, a local company, on Docker container duration, and they said, well, the most common duration is 1 minute, and the second most common duration is 0 minutes. You don't have enough resolution here to measure Docker if you're reporting things on 1-minute boundaries. And then the other problem I was talking about was if you're trying to monitor a system, you don't want to be the thing that dies first. Like your system suddenly gets unhappy, and it starts spewing logs about how unhappy it is, and your monitoring system falls over, and now you're blind and your system's down, and that's, So you basically need to build a system that can scale and stay up when everything else is down. Otherwise, it's not giving you what you need. And then the other thing was just the applications that were starting to come up couple of years ago, obviously, were distributed ephemeral cloud-native applications. Since then, we've seen sort of containerized and now the serverless applications. I'll talk a bit about that later. So this is the things I wanted to talk about. What problems are we trying to address with monitoring? It's fairly obvious, but I just wanted to sort of be clear about that. And then a few other questions. Why isn't this already solved? Why haven't somebody already built the monitoring system that would solve the world's problems, and why are we still building new ones all the time? And then if you look at all of the sort of generations of monitoring tools, why do we keep getting disrupted, and who is being disrupted, and what are the big challenges of trying to build a monitoring tool nowadays? And then I'll talk briefly about some of the things I've been tinkering with. So this is really what monitoring's about. Measuring things that have business value, like measuring things that make customers happy, and measuring things that brokenness and fixing stuff, problem direction and diagnosis. So what is business value? Well, Mark Schwartz wrote an entire book on it, and this is the last line in the book. Unfortunately, business value is what the business values, and that's that. So not the most helpful definition, but this is an extremely good book, and you should all go and read it, because he does explain it somewhere along the way, like the business value of bureaucracies and what the hell the CIO is supposed to be doing in this new world and things like that. But what I think the business value of monitoring, depending on what your business is doing, the point is that there isn't one business value, depends what your kind of business you're running. But ultimately, we're trying to measure customer happiness on the idea that we're monitoring systems and there's something that's going to make the customer happy, and we're worrying about things that make the system cheaper to run. And then there's safety and security monitoring and compliance monitoring. And I think I see the sort of domain of this crowd, Monitorama, as really the customer happiness and cost efficiency space. If you want to worry about safety, security, compliance, you should probably be at the RSA conference or some, one of those security conferences. So think about customer happiness. This is sort of how I think about it. One of them is time to value, meaning how long did it take to get a feature out that was supposed to make the customer happy, right? If you're trying to monitor things, but what we're really looking at is trying to be efficient and not slow down the process of getting features to customers, in front of customers. Customers get happy if the systems are available when they want to use them, and they get happy if they respond quickly and don't sit there doing little spinny beach ball things. So that's pretty obvious, but I just wanted to state it. On the efficiency side, you want high utilization. So obviously that makes it more efficient, but the utilization has got to be reasonably optimized. It's not just like you could just run CPU soakers all day and hey, I'm 100% busy, but I'm not doing anything useful. So you can go in and make something much more optimal and tune it up, and then maybe your utilization goes down for a bit until you resize everything. The other thing that's really drives a lot of the cost is automation. There's a lot of manual stuff, and the more you can automate, the cheaper it gets to run. So really, just thinking about that, why isn't this already a solved problem? This hasn't really changed for years. Why hasn't somebody built an amazing system that did this, that everyone uses? And why isn't there just one standard that does monitoring? Actually, there was an attempt to do that, and I was actually on a standards body in the 1990s for the Universal Measurement Architecture. Has anyone heard of this before? Anyone? No, exactly. Right. All of the Unix vendors got together. We standardized all the metrics so that we would all collect to them. We'd have the same name. We'd have metric IDs. There was a whole hierarchy of metric IDs. And if you want a standard Unix metric ID space, you could just go and adopt this standard because it's a fairly well thought out one. And we all gathered together, and then Windows NT appeared, which had a totally different metric space. And we just went, oh, crap, and gave up. So, and now everyone does it differently. So let's think about this. There's an evolution here. We have challenges. We keep having different changes. The platform changes. The things in the platform change. The hierarchy in the platform keeps changing. There are new interfaces for collecting metrics. There are new metrics within those interfaces. There's a new schema in the data store where you're trying to save all these metrics. And then scale keeps getting bigger, and systems keep getting more ephemeral. And what happened was in each generation we had different vendors and tools. And I don't have any mainframe people here. Any old mainframe people? So it's a young crowd, right? Maybe there's one or two people that remember mainframes. But mainframes had it pretty much sorted out. This thing called SMF, and you could gather the data, and there was an entire tools ecosystem around mainframes. In the 80s, we had mini computers. Oh, we started again. We had to build a whole new ecosystem. Then I used to work at Sun in the 90s. That's where I really got into monitoring and all the tools. Again, a different tools ecosystem formed. And then we had a whole ecosystem around Windows. And Linux, and then you got VMware. Oh crap, now we have virtualized things. So there's a new level in the hierarchy. We've got VMs and machines that they're running on, and we have to go deal with that. And then the Blade chassis has a whole bunch of stuff that it can do too. So these new entities are appearing. And then we went to cloud. Oh crap, now we have APIs for doing everything. And containers came along, so now we've got containers in VMs on machines, and everyone's going, oh crap, now my schema changed again. And now we have serverless, and so these machines only last for half a second, and we're trying to deal with that. So you can see that why it changes. So why didn't one vendor just sort of keep just adding the next feature? And there's a really deep, interesting thing here, because the cost per node keeps dropping and people get locked in and they get disrupted. Because each of these new vendors that comes in effectively has a new schema that describes the new way of storing this new type of data. But they also have a radically lower cost per node. And if you're existing selling stuff at this price point, the next generation is typically an order of magnitude cheaper. And the reason for this is that we used to spend millions of dollars on a mainframe upgrade. In fact, it would be like your annual upgrade. We would sort of hold our nose and go, this is how many millions of dollars we're going to give IBM this year. And it would go all the way to board level for approval pretty much, because it was a substantial amount of money. And you'd hire a team of capacity planning people, and you bought tools for capacity planning. You'd spend hundreds of thousands of dollars deciding how to spend millions of dollars that year, right? This is the 1970s and the 80s. It was like that. Now, you know, like a VAX or something was around $1 million, so it got cheaper. A large Sun server is sort of roughly 100K order of magnitude. Now you're going like, well, I can't really afford to have $100,000 worth of monitoring and capacity planning tool for a thing that costs $100,000. So the price point sort of dropped to sort of 10K or something. And there's this sort of idea here, which it sort of feels about right to maybe spend kind of 10% of what you were spending on the thing to manage the thing. You don't want to spend 10 times as much to manage the thing, right? So as the thing gets cheaper, you kind of have to keep cutting the price. So it just keeps, we were down to sort of maybe blades are like 1K a core. And you can argue about the numbers, but this sort of order of magnitude. And now you've got EC2 instances turned up. Now we're going to per month, because you can turn them on and off, and you're doing it sort of by the hour, but the bill's monthly. So what are you going to pay for per instance that you're paying a few $100s a month? Well, you might spend a few tens or hundreds of dollars. And if you look at the pricing of the current product lines of people like Datadog, it kind of fits this model, right? And Datadog is kind of like the canonical sort of EC. They came along with EC2 and they sort of fit that model. And now we have, Docker comes along and, well, you're fitting a bunch of these containers and they're smaller, more ephemeral. And they, you could argue how much it actually costs, but it's more like, it's an order of magnitude less. And now we've got Lambda, which is probably, you could spend dollars a month on a particular Lambda function. And so what did it cost you to manage that dollar a month, right? You can't spend $100 on a monitoring tool to manage something that's costing you $1. So what happens every time we go through these generations is that the previous vendor gets disrupted. This is actually, if you read Clayton Christensen's book on disruption, a new vendor comes in that is like an order of magnitude lower cost per thing, and you can't compete, because if you just change your pricing, you just tank your revenue. People can't afford to do that. And your current product line also doesn't really understand the new thing. So we've seen the old creaky vendors try to add cloud, but the really cloud-native vendors have done very well here. And now we're seeing container-native vendors appear, and we haven't quite seen the sort of, serverless native vendors appear, mostly because they're trying to figure out how to make money off things that only cost $1 a month. It's a different, so this is part of the challenge, right? This is the challenges for monitoring. And then there's this whole vendor landscape. And I was going to put vendors on this, but I thought I'd annoy people. So I have this thing called the tragic quadrant. Pretty much everything is started in the bottom left corner, most of the tools you use. And then there are a few kind of, I can sort of handle containers. And that Lambda thing, maybe if I ever squint at it, I could at least collect some numbers from it, but not really handling Lambda. And then on the other side, I've got scale. And most data center enterprise things, hundreds to thousands is a reasonable size. But if you look at, the sort of the large, Facebook, Netflix, Google, we're in hundreds of thousands to millions, and they had to build their own tools to do that. So here's the little thing. If you're a vendor, tell me where you would like me to put a dot on this thing. And if I get enough people sort of arguing, I'll argue back and I'll sort of say, no, I think it belongs here. But I'm going to see if I can actually place some dots on this little thing. And then we can track them over time. Maybe every Monitorama will do, okay, we got some new dots and some people moved up and to the right and got better, right? So what's the largest installation that a single instance of your monitoring tool can manage or has managed, right? That's kind of the x-axis. And the right axis is, like, seriously, are you doing containers, or are you just grabbing some numbers out of a Docker daemon occasionally, right? Or are you actually mapping what's going on inside them? Anyway, all right. Tinkering. I've been playing around a little bit, building some things. And one of the things I've been doing in this space is building a simulator that simulates large-scale architectures and interfacing it to real monitoring tools to annoy them and break them and, like, pretend that I've got 10,000 machines and have them fall over. So that's the general idea. It's open source. It's a Go program. It's sort of, if you squint at it, it's kind of an actor-based simulator written in Go. And it generates nice little diagrams that show you what the architecture looks like. It also collects trace records for end-to-end tracing, sort of the APM Zipkin-like tracing. And I've actually connected it up to Zipkin. So this is what it looks like if you generate a trace. This is an end-to-end trace through the system. Each of the little icons on my diagram here is a Go routine, and each link between them is a Go channel, which is pretending to be a network connection, and each of the Go routines is pretending to be a microservice, right? So on this laptop, I can run 100,000 microservices in my simulator in a couple of gig of RAM. And it runs about 100,000 messages a second when you sort of pass things around in it. So this is one message. It's hard to read with the resolution here, but this end-to-end is about 100 microseconds. If you did this in the real world on a real system, it would be more like 100 milliseconds, right? So I'm running about 1,000 times faster than the real world, which is a useful thing if you're building a simulator. If your simulator runs as slowly as the real world, it's not really useful. But it's got a nice few orders of magnitude improvement, so you can actually do some quite interesting things with it. So one thing I did was tracing. I also managed to figure out how to get Neo4j hooked up to it, so you can store the graph that I'm generating and the trace records into Neo4j, and, you know, it kind of works. So I'm still debugging a few things around that, and I'm still trying to understand Neo4j, but that's a different problem. Basically, I can now fill up a graph database with an interestingly large architecture diagram and then extract bits of it with Neo4j queries. So I'm sort of playing around with that. So. And then the other thing I did was I started measuring response times inside this system and measuring the distributions of response times. And there's another tool I ran into recently, which I think you might find interesting. It's called Guesstimate. It's hard to see on here, but it's a spreadsheet-like thing. It runs in a browser. It's publicly available. You can just go visit it on the web. And by default, all of your models are public and shared with everyone else. So I've got a shared model. If you give them a couple of dollars a month or a few dollars a month, you can get a private copy to sort of hide your predictions things. And basically it's a modeling tool for dealing with distribution. So every node in your spreadsheety-like thing that you create formulas on is actually not just a number, it's a distribution. And what I was playing around here with is response time distributions, because response times aren't an average number. They aren't a, percentile. You look at the 99th percentile. That's what people typically look at. But the problem is that the shapes of these response times aren't just a nice normal curve. And in fact, using this model, I produced this thing which basically says, well, let's pretend I have a system that's got a memcached and a MySQL, and the MySQL has a disk. And those are the three things, and each of those three things has a different response time, and your cache hit rates mean that you take a different path into the system at different times, each request. And then if you look at the response time distribution for that, it's got three modes. It's got I managed to hit memcached and it was quick, which is that first spike. And then I hit MySQL and I got data without having to go to disk because it was cached in the memory part of MySQL. So that was a bit slower. And then finally there's I had to go all the way to disk, which is even slower. So the characteristic latencies turn up as different spikes in the response time distribution. And as you change the hit rates, the heights of the spikes change, but the positions don't. So actually, if you look at these response time distributions, you get an enormous amount of insight into the structure of what's going on in your system. So This is a model system where you just sit and play with it and you can examine what would happen. And it's not that hard to figure out, but if you want to go build a model, you can go look at my model and sort of copy it, and happy to help anyone that wants to play with it. So I was inspired by this to add things into my simulator to actually gather the histograms. And if there's a few monitoring toolkits out there that collect percentiles, and they tell you what your percent busy is and your 99th percentile response times and things. It turns out in order to calculate percentiles, you actually need to collect the histogram and then throw most of the data away and just tell you what the percentile was. But if you actually print it out, you get a full histogram. Well, this is wonderfully accurate. It does look better than that on my thing. Anyway. This is the buckets for the histogram. You can see the numbers, and there's a bit of sort of ASCII art showing you what it looks like, and then I pulled it out and did an actual graph to show you what it looks like. And you can see the cache hits and the cache misses for a very simple model that I was running in my simulator. And so I've got 2 spikes, so it kind of does the right thing. So this code is actually was put back into GoKit. So if you're building a microservices architecture in Go and using Peter Bourgeon's GoKit system, there is a metrics subsystem in that which backends into Prometheus and things like that. And that has this code was, the code to get these histograms out is actually already there. So if you use that system and you just do a print on your histogram object, it will actually give you a printout that looks like this, right? So I worked with, I sort of hacked this together, and then luckily Peter liked it enough to put it back into the system. So what I'm really saying here is that yes, you can draw little lines, squiggly lines on strip charts against time, but the really interesting things in these architectures are the response time distributions. And if you can actually start getting those out, and then you can manipulate them, that spreadsheet thing, guesstimate, it's using Monte Carlo analysis in order to generate its results. And most people get a deer in the headlights look at that point and sort of go, I don't know what you're talking about. But basically think of it as a way to combine distributions together as sort of fuzzy numbers, and you can sort of add them together and you can multiply them and whatever. So that's really what it does. All right, so let's talk about serverless for a bit. I'm using that as an umbrella term to mean, otherwise we'd just be calling it AWS Lambda and clones. It's just become the name that people are using for it, so I'm not worrying about the definition of the name. But Lambda has now got quite a lot of production examples. I keep running into people who are really using this thing in production, and there's a number of reasons why, which we'll get to. Google and Azure have launched their sort of clone-like things that are very similar. IBM came out with an open source implementation of something that's pretty similar. So now people, originally when Lambda came out, people said, well, that's a very, very specific looking thing, and I'm worried because I'm getting locked into an architecture which looks like there's really only one thing that's even like that. Now all the other vendors have said, yeah, we have a thing like that too. So there's at least some idea of sort of conceptual portability, even if the code isn't exactly the same. And there's a few startups making it easier. So we have serverless, but unfortunately that also gives us monitorless. This is your architecture diagram. There were no machines there to monitor. Sorry. There's nowhere to install anything. I've got my web services sitting there, but there's no instances. There's no, where did I install the agent? Where's my collectd? Sorry, it's not there. And then, okay, like, oh, one came in. That was one request decided to bounce. And that's not one request. That's a series of events that triggered a series of Lambda functions that just sort of bounced along. So, and you could look at the accounting sort of log file that Lambda generates, or these things will generate and pick it out, but you're not tracking this stuff. And then there's all these other functions that are sitting there that haven't been invoked yet, so you haven't monitored them because they don't really exist yet. So this is an interesting challenge. And the problem here is that the thing you want to monitor only exists for short periods of time, and it goes away again. So you have to kind of think about how you're going to abstract monitoring in that environment. Just kind of some more real architectures. There's a few reference architectures AWS have published for interesting ways. So if you want to kind of look at how people are really using it, there's some good examples there. All right, so what's the programming model here is it's not that different, but it's an event-driven function model. You define your function, you feed it an event, it wakes up, it does something, it goes away again. It has a lot of role-based permission systems in it, so you have to be in the right role in order to receive that event and to generate whatever other events go downstream. And the security model is effectively whitelisted. By default, a function can't do anything. You have to explicitly turn on, you can read from this S3 bucket, and you can write to this Kinesis log, and you can call this API somewhere over here, but you can't do anything else. So it's a very secure environment. And a lot of people are actually looking at this for building sort of business systems, particularly back-end sort of business workflow systems that are incredibly secure because, like, how do you break into it? There's no attack surface left. There's nothing there. It's not running. Like, where would you install your exploit, right? The thing doesn't live long enough to be exploited. So there's some interesting things here. And also because they're waking up and doing something and going away again fairly quickly, it tends to be that you can do this with JavaScript or Python. So your chunks of code, your little microservices are pretty simple. I think it's generally, you can put an entire Tomcat server and run it for 5 minutes if you want to. It just doesn't feel right. It's not a good use for the thing. So the big multi-threaded Java applications, you can run them here, but it generally gets less and less efficient. So why is this interesting? It's very efficient. There's no agent running on this system, right? If you actually look at the machines you've got and you say, well, yeah, right, it's sitting there and it's 10% busy, yay, cool. Well, it turns out 5% of that's the monitoring system and 4% is the security scanner, 1% is you actually doing some work on it. That happens a little bit too often. And yeah, but I've got the other 90% for when I really need it, right? But it turns out with this mode, there's no overheads, and then there's no charge when it stops. So the system, you're only paying for this 100% utilized resource. So this is, the public cloud model for this, right? This is the way Lambda works. You're charging for every 100 milliseconds you use, right? And then you don't have to provision extra capacity in case peak traffic turns up because it does that for you and you only pay for exactly what you use. So typically you would oversize a system, it would be underutilized, and it would have agents on it consuming stuff. And when you combine all these things together, I'm getting quite a few anecdotes that say, well, I replaced this system, which was a reasonably sized system, with this other Lambda-based system, and it cost 1%. Of what it cost before. And if it's 20% cheaper, you'll go, yeah, that's vaguely interesting. If it's a tenth of the price, you go, I'll get to that fairly soon. And if it's 1% of the price, and so management goes, hang on, guys. What, really? I want someone to find out whether that works or not now, right? And so, there's some trivial examples like, somebody replaced a DigitalOcean droplet that was costing them $10 a month, and it cost them 8 cents a month to replace it. Or a few $100s a month went down to a few dollars a month. So I've got a few data points on this. There's a training company, I think they're called a Cloud Guru, that run all their back-end on Lambda, and it's just sitting there. And when no one's in a training class, the system's still sitting there. They turn up in the class. They don't care how many people turn up in the class. They beat on the system, and it's exactly the right size it needed to be. And when they stop, it stops. And they're extreme, and their costs are low enough that they no longer care about how much it costs to run this stuff. Whereas normally, if you have to set up a system to support a training class, it's kind of a hard thing to do. So this really is very good for low traffic, corporate IT in particular, and these very spiky workloads. If you've got a completely flatline workload that's just crunking all day, yeah, get an instance for that. It'll be cheaper. But there's an awful lot of spiky workloads out there that are finding their way into this model. All right, so that's interesting, but then there's a whole bunch more issues. There's a little bit of tooling around it, but it's still pretty clunky. What happens if the serverless service goes down? Which has happened, unfortunately. It happened a little while ago. And it's like, yeah, well, the OS East no longer has any Lambda functions running. It's not a good idea, not a good place to be. So you have to figure out patterns where you're distributing your traffic to more than one region or more than one zone or something like that, maybe more than one cloud vendor. So there's some issues there for, like, there's a big common failure mode. And then debugging it, right? This function just fails in the middle. Well, how do I figure out, well, I didn't have the permission set up right is what's normally wrong, or it's just like blew up for some reason, or you've got, left pad happened or something. I was thinking when everyone's moving in, you've got left pad here and right pad here. That's kind of the algorithm, but everyone's still running npm install and waiting for it to finish, so, oh well. So you've got that, and so debugging is a problem, and then monitoring, right? Which is why we're here. How do you monitor this thing? And you could kind of hook up an end-to-end tracing system like Zipkin into this, and I think that's probably where we'll end up. And you can kind of stitch it back together out of the event log that is generated by the serverless system. And there's an event, there's a log entry that says this thing woke up, this was the incoming event, and hopefully it logs what the outgoing events are, and you can sort of gather these things end to end. The other interesting thing, and I've seen a few cases here, is AWS has now instrumented just about everything AWS does with Lambda function emitters. So every time you fire up an AWS instance, you can attach a Lambda function to that figures out which IP address you want to hook up to it, or what, you can just do things. Anything you want to do at invocation of a thing, you can attach a function to that will just do that. So there's a whole level of automation and building a monitoring tool out of Lambda, right? Not talking about monitoring Lambda, I'm talking about building a monitoring system that has Lambda as its data source for doing stuff. So I think there's something interesting there that hasn't really happened yet. So that all sounds like fun, and of course the people that have their on-prem side saying, after like sniping the fact, yes, really there are servers there, yes, we know there are servers there, and we can call cloud buildingless if you like, because there are still buildings, but I don't care where they are anymore. So there's some DIY on-premise challenges for this, right? If you try to build your own, if you're trying to run the IBM OpenWhisk stuff online because you kind of like the programming model, you have a bit of a problem. The scheduling and startup latency is an issue, right? These things, you have to kind of get to the point where you can run a single event, and it's probably a fraction of a second is quite a common use case. If it takes you more than that time to figure out how to start something up, your overhead gets to be too long. And then you want to monitor it, and then you want to charge for it. And if you spend several seconds per invocation just doing that, then you can't really afford to have something that lasts half a second running in the middle. So that's kind of a challenge. You've got to make it incredibly efficient. And I think that the AWS folks spent quite a long time making the system efficient before they launched it. Other people are still in catch-up mode, and they're trying to figure this out. My sort of analogy for this is, if you're standing next to you've got a choice. There's Burger King and McDonald's, and you're just going to get a burger, and it's going to take you, a minute to get a burger. You don't spend all day agonizing over which one to go to, right? If you're going to go to French Laundry or Manresa and spend $1,000 on dinner because there's the incredibly high-end restaurants, you could spend a month planning that, and you probably have to book it 6 months in advance just to get in, right? So there's if something is big and expensive, you can spend time planning for it and deciding it. As things get to be faster and faster, you have to make a snap decision and just get straight in there. And then if you're running a rack of machines that is your, say IBM OpenWhisk machines, well, how many machines do you need? Well, I don't know. How many Lambda functions are going to be invoked at once? You have to do some sort of capacity planning, capacity modeling thing. And the smaller your environment, the harder it is to have enough capacity to not run out at awkward moments. So you have to have, this is one of those things where a centralized resource with lots of people sharing it is going to be easier and easier to capacity plan it. All right, so wrapping up, these are the challenges, really. There's just too much new stuff to deal with, and every time new stuff comes along, it tends to break all our monitoring tools, and we have to start again. And typically, some vendor eventually goes out of business, and a new vendor comes in. Even for monitoring stuff that we're doing on, even open source free monitoring tools, you still have to pay for machines to run them on, and the cost of those machines is actually pretty significant. And this, going back to sort of my Netflix days, the proportion of Netflix's AWS bill spent on monitoring was way too high, and it probably still is way too high, but a few years ago it was, a number that was unreasonably too big. So it wasn't the fact that, and that was for the system we built ourselves, right? And then there were engineers trying to look after it. And the systems are getting more and more ephemeral, and that's not going to go away. You've got to figure out how to deal with it. And there's this price disruption problem that keeps going along, So how much can you charge per Lambda function to monitor it? And what does even the cost model look like if you're going to build a SaaS product to manage it? All right, so thanks for that. That's it. I'm doing another talk on Wednesday night at Puppet Labs. It's the local Docker meetup, and I'm doing a microservices architecture talk there. And I'm going to be around at a few more places this summer. I'm going to be at GopherCon in July, and What day is it?
August 1st through 4th.
August 1st to 4th. I'm going to be at the spring conference in Vegas. Because Bridget made me say that. And a few more things. But anyway, so I'll see people around the conference, and I'll be around Wednesday night if you want to hear about microservices. And then finally, these are just full disclosure, these are the companies we invested in recently and whatever, so it's like payday stuff. So if you want to talk to me about any of these guys, then I that's part of my day job to look after them. All right, so thanks very much. Cheers.